In a groundbreaking discovery, scientists have found that rocks from Mars's Jezero Crater, which likely predate life on Earth, contain signs of water. This revelation comes from a study published in the journal AGU Advances, where researchers from MIT and NASA analyzed 7 rock samples collected by the Perseverance rover. These samples, gathered from the fan front of the crater, contain minerals typically formed in water. This suggests that the rocks were either deposited by water or formed in its presence, indicating that Jezero Crater was once a watery, potentially habitable environment. The Perseverance rover, a marvel of modern engineering, embarked on its mission to explore Mars' Jezero Crater in 2022. During its exploration of the crater's western slope, the rover collected 7 rock samples from a fan-like region believed to be an ancient delta. This area, known as the fan front, is thought to have been created by sediment flowing with a river into a now dry lakebed. The rover drilled into the Martian bedrock, extracting pencil-sized cores, which were then sealed in tubes for future retrieval and analysis on Earth. The analysis of the rock samples revealed the presence of minerals that typically form in water, such as carbonates and sulfates. Carbonates, which are similar to those that form reefs on Earth, suggest that the environment may have been conducive to preserving fossils of microbial life. Sulfates, on the other hand, indicate the presence of very salty water. While such conditions might not be ideal for life, they could help preserve any signs of life that existed in less salty layers. This discovery confirms that water activity was significant in Jezero Crater's past. The presence of water in Jezero Crater raises the tantalizing possibility of ancient Martian life. According to Tanja Bosak, the study's lead author and professor of geobiology at MIT, these rocks confirm the presence, at least temporarily, of habitable environments on Mars. The samples, some of which may date back over 3.5 billion years, are the oldest rocks potentially deposited by water that scientists have ever examined. This makes them the most promising candidates for preserving fossils and signatures of life, offering a glimpse into Mars's ancient past. While the presence of organic matter, the building blocks of life, remains inconclusive, the potential for discovering ancient life persists. The rover's instruments, including the scanning habitable environments with Raman and luminescence for organics and chemicals, Sherlock, detected signals that could indicate organic molecules. However, these signals might also be attributed to non-organic substances, such as cerium metals. As Eva Scheller from MIT explains, the potential organic signals were strongly correlated with phosphate minerals, which always contain some cerium. This ambiguity highlights the need for further analysis on Earth. The return of these Martian rock samples to Earth will mark a significant milestone in the search for life beyond our planet. Once on Earth, scientists will have access to advanced laboratory instruments capable of detecting organic matter with nanometer-scale resolution. This will allow for a more definitive investigation into the potential for ancient life on Mars. As Tanja Bosak notes, on Earth, once we have microscopes with nanometer-scale resolution, and various types of instruments that we cannot staff on one rover, then we can actually attempt to look for life. The future of Martian exploration holds exciting possibilities.